Hello there and welcome to another Math movie media production where you get to play the therapist and solve all of math's problems. Today, we're going to be covering the topic of special systems of linear equations on page 84 in your math book. Tons of fun follows, so let's get there and get started. The first thing that we're going to be doing is solving a special system of linear equations. We're jumping right in. Remember, in the last video, we learned that a system of linear equations is where we have two linear equations together. Here we have that. And we add the word special to the beginning of this unit because there's going to be some special circumstances that we're going to look out for. So remember, one of the ways that we could do this is we could solve this by graphing, and wherever they intersected is the solution to that system. So they've done that for us already in this example. We're going to graph this. The y-intercept is at 1, and you go up 3 over 1, up 3 over 1, or down 3 to the left 1. And that's y equals 3x plus 1. And then we're going to graph the second linear equation at -5. And we're going to go up 3 over 1, up 3 over 1, up 3 over 1. And you should notice that these lines never cross, do they? These lines will never cross. We call that parallel. Just like the white lines on the road that never cross, they wind as the road crosses. And when the road is going straight, those lines go straight. Those lines will never intersect. So these lines are parallel. They'll never intersect. So whatever x and y that you put into these two equations, they're never going to have a solution. Your answer for this is no solutions. Okay, they're parallel. No solutions. Now you could identify this without graphing it, and let me show you how. The first way that you can identify parallel lines and that your answer is going to be no solutions is by looking at the slope. When you look at the slope, what do you notice of the slope? Hopefully you said that they're the same. Both of these lines have the same slope of 3 over 1, correct? Right? That means half of our criteria. The other thing that you need to do is you need to look at the y-intercepts. Are they the same or are they different? They're different, right? So because they have the same slope and different y-intercepts, then they're going to be parallel and your answer is going to be no solutions. So let's recap. Two linear equations with the same slope and different y-intercepts will always be parallel, and that means you're going to have no solutions. I would write that down and remember that one. Our next special circumstance I'm going to do for you right here. We have two equations that form a system of linear equations. One of them is already, one of them is already in y equals mx plus b form, this one right here, and I'm going to put the other one, this one is in standard form, ax plus by equals c. I'm going to put this one in y equals mx plus b form as well. So to do that, I'm going to subtract 4x from both sides. That leaves me with 2y equals a -4x plus 8, and then I'm going to divide by 2, divide this by 2, and divide that by 2, and I'm left with y equals a negative. Can you simplify this right here? Of course you can. Divide by 2, the top by 2, you're going to get a -2 over 1. And can this be simplified? 8 over 2, of course that can be simplified. Divide by 2 again, and you should get 4 over 1, or just positive 4. So now this is in slope-intercept form, and so is this. What do you notice about our two lines now? Your answer should be that they're exactly the same, right? Y y equals negative 2x plus 4 equals a negative 2x plus 4. If you were to graph these, what would happen? You would graph this one, and you would go to graph this one, and it would be what? The exact same line, wouldn't it? These two lines are going to lay right on top of each other, meaning that there's infinite solutions. These two lines are always going to intersect. I can't even spell, that's why I don't do language arts. Infinite solutions. These lines always intersect because they're going to be on top of one another. So remember, if you have the same line, it's infinite solutions. So here's a practice problem for you to figure out. Pause the video, work it out, and see what you can come up with. All right, I see that I already have one that's in slope-intercept form. But this one is not, so I'm going to put this in slope-intercept form. And I'm just going to rewrite it underneath here so I have a little bit more room to work. Just rewriting the equation. I'm going to add 4x to both sides. Remember doing the inverse operation. Leaves me with 4y equals 4x, that's plus 8. Divide by 4. Divide by 4, divide by 4, there. That cancels out, and I'm left with y equals 4 divided by 4 is just 1x, or x, and 8 divided by 4 is 2. Here's one, here's the other. Think back to what we just talked about. They're exactly the same, which means they're the same line, which means that my answer is infinite solutions. If you got that, give yourself a pat on the back. There's 3 things that you just need to remember from this lesson. There are 3 possible ways that a system of equations is going to have a solution. We covered number 1 in the last section. There might be one solution where 2 lines intersect. For example, 1, 3. We did that in the last video, remember? When we had intersecting lines, that's one possible scenario. The second possible scenario was from example number 1, where we have parallel lines and they never intersect. And in that case, we have no solutions. And in the third example, we'll end up with the same exact line. They'll lay right on top of one another. And in that example, we have infinite solutions. So when solving your system of equations, those are the only 3 possibilities that you're going to have. That wraps us up for today. Short and sweet and to the point. So that leads us to our joke. What did one snowman say to the other snowman? Smells like carrots. All right, guys. Hope you guys learned something today. Hope you guys have a good one. We'll see you next time. And remember, God loves you.